Okay. So, so just to kind of remind you, we do have the assignment. It's in our Unit 8 folder. I'm also going to pull up real quick just to see how yesterday went for the class, and I'll try and look to see if it was you guys specifically. Because if it wasn't, then I don't want to waste your time there. But let me pull up, see how it went yesterday. Okay, so looking here, it looks like we were pretty okay. Number 3 gave some people issues. I know there was one typo on that, so it might have been before we fixed it. But I can definitely pull up number 3 real quick just to take a look together. Yeah. Okay. So, so for this one, this was not the one with the typo, but it says correctly fill in the setup, blah, blah, blah. And so you wanted to focus in on what exactly we were doing. So if we were starting with moles, we're heading to mass, you wanted to go moles given, and then you bring moles down to the right. So don't even focus on the other part of the 2 labels. We wanted to take moles down to the right, and then we would follow up with the molar mass on top. All right. And so you had 2 questions kind of talking about the setup. So hopefully that went okay. I'll go and look a little further, but that was kind of the only one that the class had issues with. So I'll go ahead and move on to today's stuff. So today we're still doing the same thing as far as the setup goes. The only thing that's different is that now we're bringing in particles. All right. And a particle is going to be, I always like to say they're the funny chemistry words. So anytime you're reading through a problem and it says, hey, you start with this and you want to find out some chemistry word, right? So atoms, molecules, formula units, particle. That's going to be your cue to use Avogadro's number. And that's what the whole thing is about today. Okay. And so your little assignment will be down here. All right. So I'm going to write all over the Jamboard. This is the same Jamboard that we used yesterday. And I think you might be on there already, which is good. And if not, here it is. Okay. So if you needed to see it up close, you can do that. Otherwise, you can look at your Zoom screen. I'm starting on slide 1, and then we're going to kind of just keep on going from there. So basically, the only thing changing about today is that we have Avogadro's number presented to us. Okay. So Avogadro's number, and this right here, this is found inside your little periodic table that I shared with you guys way back on like the first day of school. But I can also pull that up real quick right here. This reference material stuff right here, it would show up like that. And if you kind of scroll down to the second page, you have Avogadro's number listed right there. And then obviously your periodic table is down at the very, very bottom of it. Okay. So from this, okay, I went ahead and took a little snip and I found Avogadro's number. So it's 6.02 times 10 to the 23rd particles per mole. So now we actually get to use the fun Avogadro's number that you always hear about like on mole day and things like that. Okay. And so I went ahead and defined what particles were. And I say this in the video as well. I tell you that it's atoms, it can be molecules, it can be formula units. Molecules is the term that we're using for covalent compounds, so 2 nonmetals together, 2 or more nonmetals together. And then formula units is what we use when we have an ionic compound. So it's very specific to either of those. But for the most part, this school year, you guys are getting the problems usually presented to you, so I'm not going to be asking about that too often. But I do want you to recognize that they both look like compounds, and that's what we're talking about. All right, so just like yesterday, when we had our, don't want to turn it, just want to make it bigger. Hold on. There we go. So we already saw this whole idea that we're always going to start with what we're given, and that goes into the first box, right? So we're always going to start with what we're given. Words come down to the right, kind of like what I just showed you on that problem from yesterday. Words come down to the right. So if I start with grams, grams comes down to the right, and then I go to moles. It's always going to be a 1 with the word mole and molar mass with grams. All right. So as long as you filled in that first box, this part is going to be the same, right? So molar mass goes with grams, mole goes with 1. All right. Then we also saw the example that if I start with moles, moles comes down to the right, but we still put that 1 with mole, and now we're going to be putting molar mass with the grams on top. Okay, for today, we are getting particles. Particles comes down to the right. We're still putting a 1 with the word mole. And now we're going to be replacing the particles part. So where we used to be putting the molar mass, we're going to be putting Avogadro's number. Okay, so you kind of see a little bit prettier version of it over here. And so what we see is going from particle to mole, we brought particles down to the right, and we ended up with 1 mole on top. 6.02 times 10 to the 23rd. So Avogadro's number always goes with particles. And then if we're trying to go from moles to particles, we would go moles. Moles comes down to the right, and we would have the 1 mole together, and then we would put Avogadro's number on top. Okay, but even more importantly, because we don't want to lose easy points, you got to make sure you're typing into your calculator correctly. So this right here is talking about Google Calculator. And so what you end up seeing is we're going to be doing 6.02, use that exponent button, and then 23. So it's something that I kind of showed you back when we first learned scientific notation when we were doing frequency and stuff like that. Okay, so these little bitty numbers or big numbers. And so make sure you're using that exponent button. I also have kind of made a point to show you guys today that some of you guys have this capability. There is an app on Chromebooks that is available. It's the TI-84 one, and I just found the little sheet that I'll probably post for the weekend. But if you do have this calculator, you can push this little EE button that's way down here. So if you have even a scientific calculator at home or whatever, the EE button is also found on there. So that's what you're looking for. You're either looking for exponent or you're looking for EE. Okay. And so I wanted to make sure you guys knew that that was there. And so you would basically type in 6.02, and then you would push second EE and then follow up with the 23. So it works the same exact way, but I just want to make sure you guys knew that you have that. Okay. So for the rest of this, let me go ahead and go to the next slide. I'm just going to show you 2 quick examples, and then I'll probably let you guys go since there's only 2 of you. Again, if you guys have any questions, please unmute your mic. Just let me know or type it into the chat. That's open as well. Okay. But what I've got here is I have my 14.33 moles of carbon dioxide. Okay. And I want to know how many molecules is that. So notice that I used, this is carbon and oxygen. Those are 2 nonmetals. So I used the word molecules. I could have said particles. Okay. But I have to specify that I want the whole molecule together. All right. So when I have this, what I'm going to start with is just like yesterday. So I'm going to start with what they give me in the problem. So that 14.33 moles of carbon dioxide. Okay, we don't write in this box, but I'm going to bring my words down to the right. So I'm going to have moles of carbon dioxide right here. Okay, and I'm going to change into what I'm wanting to convert into. So moles can go any direction. Okay, and I'll kind of show you guys something about that on Monday. But for this, what we see is that I've got my 1 mole of carbon dioxide. So this is a guarantee, 1 with the word mole, okay? Then in the other one, we're going to put Avogadro's number. So 6.02 times 10 to the 23rd molecules, okay? So now that I have all this written, now we can actually start typing it into our calculator. And so we're going to quickly go 14.30, just kidding, 14.33 times 6.02. I'm going to push EXP, the exponent, 23. I'm going to push equals, and then I'm going to divide by 1, and I'm going to follow up with that answer. So I have 8.626. We have 4 sig figs, so I'm going to go 8.627. And then that exponent part is right here. So we have this E plus 20, E plus 24, right? And so, and this should make sense, right? We're trying to go from this package number to how many individual pieces are in that package. So we want this number to get bigger. So this means times 10 to the 24th power of molecules. So we have lots of individual pieces inside of that package, okay? So this definitely makes sense. And remember, this times 10 to the 24 means that this decimal is going that direction 24 times, okay? That's what that means. All right. The other example is going the opposite direction. So I'm going to say, okay, if I have 8.32 times 10 to the 21 formula units of magnesium oxide, okay, I'm using formula units because it's ionic, and I want to know how many moles that is. I'm going to start with what I'm given. So notice it's still the same outline. 8.32 times 10 to the 21st formula units of magnesium oxide. We're not going to write in this bottom one. We're going to bring words down to the right. So notice I don't even deal with numbers until I've moved all my words around. So I have my words down to the right and moles is on top because that's what we're converting into, right? So once again, we have that guarantee that 1 goes with the word moles, okay? And then we can fill in for formula units, we can fill in that Avogadro's number. So once we have that, now we can go ahead and type that into the calculator. Okay, we're going to go 8.32 EXP 21, right? So we have our 8.32 times 10 to the 21. I'm going to multiply by 1, push equals, and then I'm going to divide it by 6.02 EXP 23 and push equals. And now we have 0.01, forgot, 38. We went to 3 significant figures on this one. And this is going to be moles of magnesium oxide. Okay, so easy. It's still the same thing as yesterday, right? So just get what you're given, put that in the first box, words come down to the right, and then follow into moles, which leaves me with the last idea, which is also it's covered in the video. So make sure you take your time to watch this video. Okay. And so on here, what I kind of tell you is that you can do this whole thing in 1 step, or you can do it in 2. And a lot of people actually prefer to do it in 2. I didn't show you that part because I wanted to show you how to do it all in one big calculation, just to kind of prepare you for stoichiometry. But you can take your mass, convert it to moles, right? So mass, and we would bring molar mass down, go to moles, right? So divide by molar mass, you're now in moles. Then we take the moles, convert it to particles by multiplying by Avogadro's number. So you can do it in 2 steps, and there's nothing wrong with that. So you kind of pick which one works for you. But what you see me do down here is I took what was given, right? So this 14.67 grams of water. I brought words down to the right, okay? And then I had my grams down here. So there's my molar mass, right? Molar mass sticks with grams. We put 1 with moles, okay? And then we would convert into into particles by using Avogadro's number. So once again, we take what we're given, we divide it by the molar mass, we multiply it by Avogadro's number. That's all that you're doing in this, okay? So you can do it in 2 steps. Convert it to moles by dividing by molar mass, convert it to particles by multiplying by Avogadro's number. So that's all I kind of got for you guys. So unless you guys have questions, I wish you a great weekend and let me know if I can help, okay? Thank you for joining me today. It was awesome to have you guys here.